आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Okay, so hello everyone. Now this question over here says that comprehension given below is followed by some multiple choice questions. Each question has one correct option, so we have to choose the correct option. So we have been given this particular comprehension and we have been given this question and this multiple choices. So we have to answer the correct one. So the question over here is that which of the following pair is expected to have the same bond order? That means we have to find the bond order of these particular options and tell which of the following pairs will have the same bond order. Okay, so now in this comprehension, the important information about the bond order is this, that bond order is one of the most important parameters to compare the strength of the bond. This is something that has been given in this paragraph, and to calculate it we know that we have to first of all write the configuration, that is the electronic configuration, but not the normal way that we write, but according to the MOT, that is the molecular orbital theory. So these orders, these increasing energy orders according to the MOT have been given over here. So these are the two informations that we will require basically to find out the bond order. So let us begin with the first one, A option, that is O2 and N2. So basically in the question itself it has been given that I have just highlighted that as well, that for N2 this order will be followed. Let me write it. For N2 we will follow this order. This is for the nitrogen, and for other oxygen, fluorine and other elements we will follow this one. So over here we have actually oxygen, fluorine, it has been written already. So this is for O2, fluorine and etc. Now let us begin writing it for O2 first of all. But before that, let us revise the formula of bond order as well. So we know that the formula to calculate bond order is nothing but, let me write, bond order, it is calculated by the formula which is half times number of electrons in the bonding orbital, that is Nb, minus the number of electrons in the anti-bonding orbital, that is Na. This is the formula to calculate the bond order, and we know that the bonding orbitals are normal, that is without the star mark, and the anti-bonding orbitals are this one, that is the star one. For example, the sigma star, this pi star, these are the anti-bonding orbitals. Basically the anti-bonding electrons will be present in these anti-bonding orbitals. So let us write for O2 first of all. So let me write O2 over here, and we know that O2 has 8 plus 8, that is 16 electrons, and the order for its electronic configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So we have basically completed 8 electrons, 2, 4, 6, 8 electrons have been completed. After this we have sigma pz, 2 electrons over here, then we have pi 2px and pi 2py, so they both have the same energy level. That means one electron will go first of all over here, 1 and 1, and then pairing will happen, so 2 and 2. So now we have completed, let us count. We completed 2, 4, 6, 8, 8, after that 10, 12 and 14. 14 electrons have been completed, 2 more to go. So after this we basically have pi star 2px, pi star 2py, and they both are at the same energy level. That means 1 and 1 electron will go over there. So let us count the number of bonding and anti-bonding electrons and hence find the bond order. So let me write bond order for O2 will be equal to half times number of electrons in bonding, that is 2, 4, 6, 8 and then 10. So 10 electrons over here. So let us write 10, and anti-bonding they will be 6. So 10 minus 6. So this thing comes out to be 4 by 2, that is 2. Now let us calculate it for N2. So for N2, first of all let me write the configuration. So the configuration or the energy level according to the MOT, that is the molecular orbital theory, for N2 has been given over here. So let us write it and fill the electrons. So let me write first of all N2, which is a 14 electron species. So it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So up till here it is same, that is these 8 electrons. After that we can see that there is a difference. We have pi 2px and pi 2py, and after that we have sigma 2pz. So let me write pi 2px, pi 2py. So they both had the same level. That means one electron will go over here, then pairing will happen. Ultimately we will have 2 electrons. So now we have 12 electrons, and lastly we have sigma 2pz 2. So 14 electrons have been completed. Now let us calculate the bond order for N2. So bond order for N2 will be half times the number of electrons in bonding. So bonding, let us calculate 2, 4, 6, 8, 10. So we have 10 electrons over here. And anti-bonding we have 2 plus 2, that is 4. 10 minus 4, this gives us 6 by 2, which is 3. So over here the bond order is 3. That means they are not same. For O2 it is 2 and N2 it is 3. That means A option is not correct. So let me put a cross over here. Now let us move on to the B option, which is O2 positive and N2 minus. So for O2 positive over here, we have O2, we have O2. For O2 positive, we will have 15 electrons. That means 1 electron from this pi star 2py will be eliminated in O2 positive. Therefore, having only 5 electrons in the anti-bonding orbital. So let me write second option over here. So for second option, bond order for O2 positive will be half times 10 minus 5. So this thing comes out to be 5 by 2, which is 2.5. And now the next one is over here, that is N2 minus. So for N2 minus, after this sigma 2pz, let me write, after this we basically have pi star 2px and pi star 2py. So 1 electron will go to this pi star 2px, therefore we will have 5 electrons in the anti-bonding orbital instead of 4. So let me write bond order for N2 minus will be half times 10 minus 5. That is 5 by 2, and which is 2.5. So we can clearly see that bond order for O2 positive and N2 minus are same. That means option B is correct. Now let us look at the C option as well. So it is O2 minus and N2 positive. So let us calculate for that. For O2 minus, so we can see that for O2 minus, 1 more electron will come in this pi star 2px over here. Let me highlight that. So over here 1 more electron will come. That means we will have 7 electrons in the anti-bonding orbital. So let me write first of all option C. Bond order for O2 minus. So this comes out to be half times 10 minus 7, that is 3 by 2, which is 1.5. Now the next one is N2 positive. So for N2 positive, what will happen is, from N2 we have the electronic configuration of N2 according to the molecular orbital theory. 1 electron from sigma 2pz will be eliminated. That means number of electrons in the bonding orbital will be 9. So let us write bond order for N2 positive will be half times 9 minus 4. So this comes out to be 5.2, that is 5 by 2, that is 2.5. Now let us look at the last option, which is D1, which is O2 minus and N2 minus. So we have already calculated the bond order for O2 minus and N2 minus. So for O2 minus it was 1.5, and for N2 minus we had calculated it to be where it is, let us see, it is 2.5. So they are also not equal. That means this option is also wrong, and C was also wrong since they were different. For O2 minus it was 1.5, and for N2 positive it was 2.5. So both C and D are also wrong. So option B is correct. So with this we complete our solution. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।